The Andromeda Galaxy is larger than most people realize. From Earth, it appears as a faint, distant smudge in the night sky, barely visible without dark conditions and a careful eye. But that soft glow hides something immense. Andromeda is not just another galaxy drifting in deep space. It is a vast spiral system containing around 1 trillion stars, stretching across roughly 220,000 light-years, making it significantly larger than our own Milky Way. It sits about 2.5 million light-years away, which means that the light reaching us tonight began its journey long before humans ever existed in their current form. When we look at Andromeda, we are not just seeing distance, we are looking into the past. And yet, despite that unimaginable scale, this galaxy is not simply sitting still. It is moving toward us at about 250,000 miles per hour, slowly closing the gap between our two galaxies. In about 4.5 billion years, Andromeda and the Milky Way will begin to merge, forming a new, larger galaxy in a process that will take billions of years to complete. This future collision is not violent in the way we might imagine. The distances between stars are so vast that direct collisions between them are extremely unlikely. But gravitational interactions will reshape both galaxies entirely, stretching, distorting, and eventually blending them into a single cosmic structure. Understanding Andromeda is not just about measuring its size. It is about trying to comprehend scale on a level that goes far beyond everyday experience. A single galaxy, containing more stars than we can meaningfully imagine, moving silently through the darkness toward our own. Before we continue deeper into this journey, we truly appreciate you taking the time to watch this video and explore the universe with us. It's always fascinating to see where people are watching from, so feel free to share your location in the comments below. And if you enjoy calm, long-form space documentaries like this, consider subscribing to the channel. It helps us create more content like this, where we slow everything down and gently explore the cosmos. Now, when astronomers compare Andromeda to the Milky Way, the differences begin to stand out in ways that are difficult to fully grasp. Our galaxy is already enormous, spanning around 100,000 light-years, with hundreds of billions of stars. But Andromeda is roughly twice as wide and contains significantly more stars. Its spiral arms are broader and more extended, its central bulge is more massive, and its overall structure is more dominant within our local group of galaxies. In fact, Andromeda is the largest galaxy in the local group, a collection of more than 50 galaxies bound together by gravity. Despite this, its true size is not immediately obvious when viewed from Earth. Because of its distance, even such a massive galaxy appears small in the sky. If human eyes were sensitive enough to see Andromeda clearly, it would actually appear several times wider than the full moon. This contrast between appearance and reality is one of the most important aspects of understanding cosmic scale. Objects in space can be unimaginably large, yet still seem distant and insignificant from our perspective. Andromeda is a perfect example of this, a colossal galaxy, larger than our own, containing 1 trillion stars, moving steadily toward us through deep space, and yet appearing as nothing more than a faint blur in the night sky. When we say that the Andromeda Galaxy is about 2.5 million light-years away, it sounds precise, almost simple, like a number we can file away and move on from. But that number hides something far more difficult to understand. A light-year is not just a measurement of distance, it is a measurement of time. It is the distance light travels in a single year, moving at about 300,000 kilometers per second, the fastest speed anything can travel in the universe. Even at that incredible speed, it still takes light 2.5 million years to reach us from Andromeda. That means the faint glow we see in the night sky tonight began its journey long before modern humans existed, long before written language, long before civilization as we know it. When that light first left Andromeda, Our distant ancestors were still learning how to survive on a very different Earth. Entire species have appeared and vanished in the time it took that light to cross the darkness between galaxies. And even this explanation only begins to hint at the scale involved, because numbers like millions of years and trillions of kilometers quickly lose meaning. They become abstract, detached from anything we can truly picture. Our brains are not designed to comprehend distances on this level. We can imagine kilometers, even thousands of kilometers, but once we move into millions of light years, the scale breaks down completely. It stops feeling like distance and starts feeling like something else entirely, something more like an endless separation. To try and bring this into perspective, astronomers sometimes use scaled comparisons, even though they are still imperfect. Imagine shrinking the distance between the Earth and the Sun about 150 million kilometers down to just 1 meter. On that scale, the entire solar system would fit comfortably within a small area, something you could walk across in minutes. But Andromeda would not be nearby. It would still be over 15,000 kilometers away. That's roughly the distance between continents, spanning oceans and entire regions of the planet. And that comparison only includes our nearest major galactic neighbor. Beyond Andromeda, distances expand even further, stretching across hundreds of millions and billions of light years. The observable universe itself spans about 93 billion light years across, filled with galaxies that are even farther away, their light traveling for most of cosmic history before reaching us. And yet, despite all of this, Andromeda is considered close. It is part of our local group, a small collection of galaxies bound together by gravity, slowly moving through space as a system. This creates a strange contrast. Something unimaginably distant is, in cosmic terms, right next to us. But distance does more than separate objects in space. It also separates us from time. The Andromeda Galaxy we see is not the Andromeda Galaxy as it exists right now. It is the galaxy as it was 2.5 million years ago. Any changes that have happened since then are still hidden from us, their light still traveling through space, not yet arrived. This means that astronomy is always an act of looking backward. Every observation is delayed, every image is historical. When we observe Andromeda, we are not seeing a present moment, but a snapshot from the distant past, frozen in light. And somewhere out there, far beyond what we can currently see, the real Andromeda continues to move, evolve, and change, quietly approaching us across a distance so vast that even light itself needs millions of years to cross it. When astronomers estimate that the Andromeda Galaxy contains around 1 trillion stars, it sounds impressive, but still distant, still abstract. Numbers at that scale don't translate easily into something we can truly picture. 1 million is already difficult to imagine clearly. 1 billion pushes the limits of intuition. 1 trillion goes beyond it completely. It becomes something symbolic rather than something real. But inside Andromeda, those trillion stars are not just numbers. They are individual suns, each one with its own history, its own system, and potentially its own planets. Many of them are larger than our sun, many are smaller, and countless are surrounded by worlds we may never see. If even a tiny fraction of those stars have planetary systems, then Andromeda could contain billions of planets. Entire systems, perhaps even entire histories, all unfolding silently within a single galaxy. And yet, when we look at Andromeda, from Earth, all of that complexity collapses into a faint patch of light. Every star, every possible world, compressed into something that seems small and distant. This is one of the most profound illusions created by cosmic scale. The universe is not empty, but it appears that way because of the distances involved. Vast systems of incredible complexity are reduced to points, smudges, and faint glows, simply because they are so far away. To understand just how dense and structured Andromeda really is, it helps to think about how galaxies are organized. The trillion stars in Andromeda are not spread out evenly. They are arranged in a vast spiral structure, with long curved arms extending outward from a bright central core. These arms are filled with younger stars, clouds of gas, and regions where new stars are still forming. The central bulge contains older stars packed more tightly together, orbiting around a supermassive black hole at the galaxy's core. Surrounding all of this is a faint halo of stars and dark matter, extending far beyond what we can see clearly. Even within this structure, distances between stars remain enormous. If you placed our Sun inside Andromeda, its nearest stellar neighbor would still be trillions of kilometers away. Space inside galaxies is mostly empty, but when multiplied across 1 trillion stars, it creates something vast beyond comprehension. Andromeda is not just large in size, but in content. It is a system of staggering complexity, containing star clusters, nebulae, dust lanes, and streams of stars left behind by smaller galaxies that were absorbed over billions of years. In fact, Andromeda has likely grown by consuming other galaxies, pulling them in through gravity and stretching them apart until they became part of its structure. What we see today is the result of countless interactions over cosmic time. And even now, the galaxy continues to evolve. Stars are born, stars die, and the overall structure slowly shifts. When we say Andromeda contains 1 trillion stars, we are describing not just a number, but an entire cosmic ecosystem, one that is constantly changing, expanding, and quietly existing far beyond the limits of what we can ever directly experience. From Earth, the Andromeda Galaxy appears quiet, distant, and surprisingly small. On a clear, dark night, far away from artificial light, you can just barely see it with the naked eye. It doesn't look like a galaxy. It doesn't look like something vast or complex. It looks like a faint, soft patch of light, slightly stretched, almost like a smudge on the sky. Many people who see it for the first time don't even realize what they're looking at. There are no clear spiral arms, no sharp edges, no obvious structure. Even when viewed through a small telescope, Andromeda doesn't suddenly reveal its full form. You might notice a brighter central region, a gentle glow fading outward, but nothing that immediately communicates its true size. This is one of the most misleading aspects of observing the universe. Distance hides scale. Something can be unimaginably large, yet still appear small and unremarkable simply because it is far away. Andromeda is not just slightly bigger than the Milky Way, it is significantly larger, stretching across about 220,000 light-years. Yet from Earth it appears subtle and almost easy to overlook. This contrast between what something is and how it appears is one of the key challenges in understanding space. Our senses evolved to interpret nearby objects, things within a few kilometers or at most within the scale of a planet. When faced with something millions of light-years away, those instincts no longer apply. The brain interprets brightness and size in ways that don't reflect reality. A faint object feels small, even if it is enormous. A distant galaxy becomes a soft glow, even if it contains more stars than we can ever count. But if our eyes were more sensitive, if they could gather more light, over time, the way a camera does, Andromeda would look completely different. Instead of a faint smudge, it would dominate the night sky. Its bright core would appear as a concentrated glowing center, surrounded by vast spiral arms stretching outward in sweeping curves. These arms would be filled with dark dust lanes, cutting through the light, creating contrast and structure. Star clusters would appear as dense regions, and subtle variations in brightness would reveal the complexity of the galaxy's shape. Andromeda would not be a small object in the sky. It would span an area several times larger than the full moon, stretching across a significant portion of your field of view. It would feel less like looking at a distant point and more like looking at something immense, something present. The reason we don't see it this way is not because Andromeda lacks detail, but because human vision is limited. Our eyes are not designed to detect faint, extended light in darkness. We see only a fraction of what is actually there. Astrophotography changes this. By collecting light over long exposures, cameras reveal Andromeda in extraordinary detail, showing its spiral arms, its structure, and even neighboring satellite galaxies. But even these images simplify reality. They flatten a three-dimensional structure into a two-dimensional view. In truth, Andromeda is not just wide, but deep. Its stars are distributed across tens of thousands of light-years, layered in space, moving in complex orbits around the galactic center. And beyond what we can see in visible light, there is even more. Infrared observations reveal regions where new stars are forming inside dense clouds of gas and dust. Radio observations show extended structures far beyond the visible edges of the galaxy. And measurements of motion reveal the influence of dark matter, an invisible component that shapes the galaxy's structure and holds it together. All of this exists within something that, to the naked eye, appears almost insignificant. This is the illusion of scale in the universe. The larger something is, the easier it can be to overlook. Andromeda is not just a distant galaxy. It is a vast, structured system, filled with stars, dust, gas, and unseen forces, quietly stretching across space while appearing to us as nothing more than a faint, distant glow. When we compare the Andromeda Galaxy to our own Milky Way, the differences begin to feel more real. It's one thing to say that Andromeda is large, but it's another to place it next to something we already struggle to comprehend. The Milky Way itself is enormous, stretching roughly 100,000 light-years across and containing hundreds of billions of stars. It is the galaxy we live in, the system that holds our sun, our solar system, and everything we have ever known. And yet, even this immense structure is smaller than Andromeda. The Andromeda Galaxy is estimated to span around 220,000 light-years, making it more than twice as wide. It also contains significantly more stars, possibly up to 1 trillion, compared to the Milky Way's estimated 100 to 400 billion. That means that if you could somehow place the two galaxies side by side, Andromeda would appear broader, more extended, and more populated with stars. Its spiral arms reach farther into space, its central bulge is more massive, and its overall structure dominates the local group. This comparison helps anchor the scale slightly, but it also creates a new problem. If the Milky Way already feels impossibly large, what does it mean for something to be twice that size? The numbers begin to stack in a way that feels disconnected from reality. Doubling something at this scale doesn't just make it bigger, it pushes it further beyond what we can meaningfully imagine. But the relationship between Andromeda and the Milky Way is not just about size. These two galaxies are part of the same gravitational system, slowly interacting across millions of light-years. They are the two largest members of the local group, surrounded by dozens of smaller galaxies that orbit around them. Andromeda is often considered the dominant galaxy in this group, not only because of its size, but because of its mass. Even though both galaxies contain vast amounts of visible matter, much of their true mass comes from dark matter, an invisible component that extends far beyond their visible edges. These dark matter halos are enormous, overlapping regions of gravitational influence that stretch out into space. As Andromeda and the Milky Way move through this shared environment, their halos are already interacting, even though the visible parts of the galaxies are still millions of light-years apart. Over time, gravity is slowly pulling them together. The motion is steady and unavoidable. At about 250,000 miles per hour, Andromeda is moving toward us, not in a straight line, but along a path shaped by gravity. This is not a sudden event, but a slow process unfolding over billions of years. Eventually, the two galaxies will begin to distort each other. Their spiral arms will stretch and twist, stars will be pulled into new orbits, and the structure of both galaxies will begin to change. Over time, they will merge into a single, larger galaxy, sometimes referred to as Andromeda. This future collision is not a catastrophic impact, but a gradual blending of two vast systems. And when it happens, the night sky of whatever remains of Earth will look completely different. The familiar band of the Milky Way will fade, replaced by a brighter, more complex structure as Andromeda fills more of the sky. This comparison between Andromeda and the Milky Way is not just about which one is bigger. It is about understanding that even galaxies, the largest structures most people can imagine, are part of something larger, moving, evolving, and interacting over timescales so long that they stretch far beyond human experience. The Andromeda Galaxy is not just larger than the Milky Way, it is also moving toward it. At first, this might sound dramatic, like two enormous systems on a direct collision course, rushing toward each other through space. But the reality is far quieter and much slower than that. Andromeda is approaching us at roughly 250,000 miles per hour, a speed that feels extreme in human terms, yet unfolds over a timescale so vast that it becomes almost impossible to grasp. At that speed, it will still take about 4.5 billion years before the two galaxies begin to merge. That is nearly the same amount of time that has passed since the Earth first formed. Everything we know, every moment in human history, every civilization, every memory exists within a tiny fraction of that timescale. And somewhere far beyond all of that, this slow approach continues, silent and inevitable. The distance between the two galaxies is shrinking, but so gradually that from one human lifetime to the next, nothing appears to change. The night sky looks the same. Andromeda remains a faint glow, and the motion remains invisible to us. And yet, over millions of years, the difference becomes real. The galaxy grows slightly larger in the sky, its position shifts, and the long process of gravitational interaction begins to take shape. When the collision finally begins, it will not look like two solid objects crashing into each other. Galaxies are mostly empty space, with vast distances between stars. The chance of two stars directly colliding is extremely low. Instead, the interaction is driven by gravity. As Andromeda and the Milky Way begin to overlap, their gravitational forces will stretch and distort each other. Spiral arms will be pulled outward into long streams of stars, forming structures known as tidal tails. Gas clouds will collide and compress, triggering new waves of star formation. Regions that were once stable will become chaotic, as stars are pushed into new orbits around a changing center of mass. Over time, the distinct shapes of both galaxies will begin to disappear. The familiar spiral structure will fade, replaced by a more irregular, evolving form. After several passes, separated by millions of years, the two galaxies will gradually settle into a single, larger galaxy, likely an elliptical system with a different structure than either of the original spirals. This process will take billions of years to complete, unfolding slowly, almost quietly, on a cosmic scale. And somewhere within that transformation, the position of our solar system will change. It may be pushed farther from the galactic center or moved into a completely new region of the merged galaxy. The night sky, if it is still being observed from Earth or whatever remains of it, will be filled with new patterns, new streams of stars, and a completely different view of the universe. What was once a distant galaxy will become part of our own cosmic environment. The idea of a collision between galaxies sounds dramatic, but in reality, it is a slow reshaping of structure, a gradual blending of two immense systems guided entirely by gravity. And it is happening right now, even if we cannot see it. It is one thing to observe the Andromeda Galaxy from a distance, as a faint object in the night sky, but it is something entirely different to imagine what it would feel like to be inside it. From Earth we see Andromeda as a whole, a single structure, its light compressed into a soft glow. But if you were placed somewhere within that galaxy, the experience would be almost indistinguishable from being inside the Milky Way. You would not see a spiral shape surrounding you. You would not see the galaxy's full form. Instead, you would see a sky filled with stars, scattered across darkness, some brighter, some dimmer, many too distant to stand out. The structure of the galaxy would be hidden by perspective. This is one of the most important limitations in astronomy. We can observe other galaxies from the outside, but we cannot easily see our own from that same vantage point. And if we were inside Andromeda, it would feel just as vast and just as difficult to interpret. The stars would be spread across immense distances, and the overall structure would only become apparent through careful measurement and mapping over time. The galaxy would not feel like a defined object. It would feel like an environment, something you exist within rather than something you observe. But there are subtle differences that would reveal where you are. Andromeda's central region is more massive than that of the Milky Way, containing a denser concentration of stars. If you were closer to its core, the night sky would appear brighter, filled with more stars packed into a smaller area of space. Star clusters would be more common, and the overall density of light would increase. In the outer regions, the galaxy would feel quieter, more spread out, with larger gaps between stars and a darker sky. The spiral arms, though not directly visible as shapes, would still influence what you see. Regions of active star formation would contain glowing clouds of gas and dust, illuminated by young, bright stars. These nebulae would appear as faint, diffuse patches of light, marking areas where new stars are being born. Over time, as you move through the galaxy, these patterns would shift, revealing the structure indirectly. And beyond the visible stars, there would be something else shaping everything: dark matter. Though invisible, it forms a massive halo around Andromeda, extending far beyond the stars themselves. This halo influences the motion of stars, the shape of the galaxy, and the way it interacts with its surroundings. Even though it cannot be seen directly, its presence is essential to the galaxy's structure. If you could step back far enough to see Andromeda as a whole, you would finally recognize its full form, a vast spiral system, rotating slowly through space. But from within, that shape disappears, replaced by a local view of stars and darkness. This contrast between internal and external perspective is what makes galaxies so difficult to fully understand. We can see them as complete systems from afar, but when imagined from the inside, they become something else entirely. Something immersive, vast, and impossible to take in all at once. The Andromeda Galaxy is not still. Even though it appears fixed in the night sky, a quiet and distant presence, it is in constant motion. Every star within it is moving, orbiting the galactic center along paths shaped by gravity. These motions are not chaotic. They follow patterns, forming the spiral structure that defines the galaxy. But the scale of these movements is so large that they become almost invisible to us. A single star can take hundreds of millions of years to complete one orbit around the center of Andromeda. That means that while human history unfolds over thousands of years, the stars barely shift in position relative to one another. The galaxy seems frozen, but in reality it is slowly rotating, like a vast system turning in silence. If we could observe it over billions of years, the change would become clear. Spiral arms would drift and reshape, stars would trace enormous arcs, and the entire galaxy would reveal itself as something dynamic rather than static. This is one of the key ideas in understanding cosmic scale. Movement exists everywhere, but it unfolds over such long periods of time that it becomes difficult to perceive. The universe is not still. It only appears that way because our perspective is limited to short moments in comparison. What makes this motion even more fascinating is that it cannot be explained by visible matter alone. When astronomers measure how fast stars move within Andromeda, they find something unexpected. Stars in the outer regions of the galaxy move much faster than they should. According to our understanding of gravity, objects farther from the center should orbit more slowly because the gravitational pull weakens with distance. But in Andromeda, the outer stars maintain high speeds, similar to those closer to the center. This suggests that there is additional mass influencing their motion, something we cannot see directly. This invisible component is known as dark matter. It does not emit light, it does not interact with electromagnetic radiation in the way normal matter does, but its gravitational effects are clearly measurable. Around Andromeda, dark matter forms a massive halo, extending far beyond the visible edges of the galaxy. In fact, most of the galaxy's total mass is believed to be in this unseen form. This means that what we observe, the stars, the gas, the dust, is only a small fraction of what is actually there. The true structure of Andromeda is much larger than it appears, defined not just by what we can see, but by what we can only infer through motion. And this motion does not stop at the edge of the galaxy. Andromeda itself is moving through space, interacting with the Milky Way and other galaxies in the local group. Its path is shaped by gravity on a much larger scale, slowly drawing it closer to us over billions of years. When we think about size, it is easy to imagine something large as something still, something fixed. But in reality, scale includes motion. A galaxy is not just an object, it is a system in constant change. Every star orbiting, every interaction unfolding, every shift happening over time contributes to something far greater than a static image. Andromeda is not just vast, it is alive with motion, rotating, evolving, and moving through the universe in ways that extend far beyond what we can easily understand. The Andromeda Galaxy may feel enormous when compared to the Milky Way, but on a larger scale, it is just one structure among many. Beyond the boundaries of individual galaxies lies something even more vast and complex, the cosmic web. This is the large-scale structure of the universe, a network of filaments made up of galaxies and clusters of galaxies stretching across billions of light-years. Between these filaments are enormous voids, regions of space that contain very little matter. When astronomers map the distribution of galaxies across the universe, they do not appear randomly scattered. Instead, they form patterns that resemble threads, nodes, and vast empty spaces. Andromeda exists within this structure as part of a small region known as the local group. This group contains more than 50 galaxies, most of them small dwarf galaxies, all bound together by gravity. The Milky Way and Andromeda are the two dominant members of this group, shaping its overall structure and motion. But even this group is not isolated. It is part of a larger structure called the Virgo supercluster, which itself is just one region within an even larger cosmic network. When viewed on these scales, individual galaxies begin to lose their prominence. Even something as large as Andromeda becomes just one point in a much greater system. This shift in perspective is one of the most powerful ways to understand scale in the universe. At first, Andromeda feels immense, almost incomprehensibly large. But when placed within the cosmic web, it becomes part of something far greater. The local group spans about 10 million light-years, and beyond that, the structures continue to expand outward, connecting to other groups and clusters across unimaginable distances. The cosmic web itself stretches across the entire observable universe, which is about 93 billion light-years in diameter. Within this framework, galaxies form along filaments where matter is more concentrated, while vast voids remain relatively empty. These patterns are not random. They are the result of the early universe, shaped by tiny fluctuations in density that grew over billions of years under the influence of gravity. Over time, matter gathered into larger and larger structures, eventually forming the galaxies and clusters we see today. Andromeda is a product of this process, a single node in a network that extends far beyond what we can observe directly. Even its future collision with the Milky Way is just a small event within this larger context. On the scale of the cosmic web, galaxies merge, clusters evolve, and structures shift continuously over billions of years. The universe is not static, and it is not centered around any single object. Everything exists within a larger framework, connected by gravity and shaped by time. When we step back far enough, the Andromeda Galaxy, as vast as it is, becomes just one part of an even greater structure, one that continues to expand, evolve, and stretch across distances that go far beyond human understanding. When we try to understand the Andromeda Galaxy, we often begin with numbers. We talk about light years, trillions of stars, and distances that stretch across millions of years of travel for light itself. But even after hearing all of that, something still feels incomplete. The numbers describe the scale, but they don't fully translate into something we can feel or truly understand. Andromeda is not just large in a mathematical sense. It represents a level of scale that challenges how we think about space, time, and our place in the universe. It takes something familiar, like the night sky, and quietly reshapes it. That faint smudge of light is no longer just a distant object. It becomes a vast system, larger than our own galaxy, filled with more stars than we can meaningfully imagine, moving slowly toward us across millions of light years. And yet, despite all of this, it remains silent, unchanged to our eyes, distant in a way that feels both real and unreachable. This is what makes Andromeda so powerful as an idea. It forces us to confront the limits of our own perspective. We are used to thinking in terms of human scale, distances we can travel, times we can experience, objects we can observe directly. But Andromeda exists far beyond that framework. It operates on timescales that stretch across billions of years and distances that cannot be crossed within a human lifetime, or even within the lifespan of entire civilizations. And maybe that is the most important part of all of this. Understanding Andromeda is not really about understanding one galaxy. It is about understanding how small our frame of reference truly is compared to the universe as a whole. The Andromeda Galaxy is just one of hundreds of billions of galaxies in the observable universe, each containing its own stars, its own structure, and its own history. And beyond what we can observe, there may be even more regions of space that remain forever out of reach due to the expansion of the universe. When we think about scale in this way, it begins to shift something deeper than just knowledge. It changes how we see everything else. The Earth becomes smaller, not physically, but in context. Our place in the universe becomes more precise, more defined, yet also more uncertain. We are part of a system that extends far beyond what we can ever directly experience. And yet we are also capable of observing it, measuring it, and trying to understand it. That contrast is what makes astronomy unique. We are both incredibly small and uniquely aware of that smallness. As you step back from this journey through Andromeda, it becomes less about memorizing facts and more about holding on to that sense of scale. The quiet realization that the universe is vast, structured, and constantly evolving, far beyond the limits of our everyday experience. And somewhere out there, 2.5 million light-years away, the Andromeda Galaxy continues its slow approach, unchanged by our awareness, moving steadily through the darkness, reminding us that the universe is always larger, deeper, and more complex than it first appears.